Bismillahirrahmanirrahim. Assalamu alaikum everyone. It's me Shahzaib Sangi from BSCS 2K17 batch, and I am here to present my presentation of the subject compiler construction. So let's start. This is the introduction. Presentation name is Shahzaib Sangi. Roll number is 2K17 LCS 41 and the subject is compiler construction. And it is submitted to Mem Koratala and Gopang, which I forget to write in this presentation. Sorry for that. So this is the course outline, which is I am going to define in my presentation. So the first one is introduction to compiler construction, and the second one is programming language translators, and the third one is types of bugs, and fourth and last topic is type checking. So this is introduction to compiler construction. What is a compiler and what is compiler construction? So a compiler implements a formal transformation from a high level source program to a low level target program. So compiler design can define an end-to-end solution or tackle a defined subset that interfaces with other compilation tools. Example, preprocessors, assemblers, and linkers. So design requirements include rigorously defined interfaces both internally between compiler components and externally between supporting toolsets. So in the early days, the approach taken to compiler design was directly affected by the complexity of the computer language to be processed. So the experience of the persons designing it and the resources available. So resource limitations led to the need to pass through the source code more than once. A compiler for a relatively simple language written by one person might be a single monolithic piece of software. However, as the source language grows in complexity, the design may be split into a number of interdependent phases. Separate phases provide design improvements that focus development on the function in the compilation process. This is the introduction to compiler construction. So the second topic is programming language translators. So a translator is a programming language processor that converts a computer program from one language to another language. It takes a program written in source code and converts it into machine code, and it discovers and identifies the error during translation. And the purpose of translator, what is the purpose of translator? So it translates high level language program into a machine language program that the central processing unit CPU can understand. This is the main purpose of translator. It also detects errors in the program. So the types of translators, there are three different types of translators as follows. The first one is compiler, second one is interpreter, and the third one is assembler. So I will define one by one. First one is compiler. What is compiler? A compiler is a translator used to convert high level programming language to low level programming language. It converts the whole program in one session and reports errors detected after the conversion. So compiler takes times to do its work as it translates high level code to lower level code all at once and then saves it to memory. So the compiler is processor dependent and platform dependent, but it has been addressed by a special compiler, a cross compiler, and a source to source compiler. Before choosing a compiler, a user has to identify first the instruction set architecture ISA, the operating system OS, and the programming language that will be used to ensure that it will be compatible. So this was the compiler. And the second one is interpreter. Just like a compiler is a translator used to convert high level programming language to low level programming language. It converts the program, but it converts the program one at a time and reports errors detected at once while doing the conversion. So with this, it is easier to detect errors than in a compiler and interpreter. An interpreter is faster than a compiler as it immediately executes the code upon reading the code, and it is often used as a debugging tool for software development as it can execute a single line of code at a time. An interpreter is also more portable than a compiler as it is not processor dependent. You can work between hardware architecture. This was the interpreter. And third one and last one is assembler. So an assembler is a translator used to translate assembly language to machine language. It is like a compiler for the assembly language but interactive like an interpreter. Assembly language is difficult to understand as it is a low level program language. So an assembler translates a low level language an assembly language to an even lower language, which is the machine code. The machine code can be directly understood by the CPU. So this is the third topic of my presentation, that is types of bugs errors. So the programmer should know the fact that there is very less chances that a program will run perfectly in first time, and it doesn't matter how nicely the designing is done and how much care is taken while coding. One can't say that the program would 100% error free. So the programmer has to make efforts to detect and rectify any kind of errors that are present in the program. But before detecting and removing errors, it is much more necessary that the programmer should know about the types of errors in programming. So these are the types of errors in programming. The types of error are classified into four categories. These are syntax error, logical error, runtime errors, and latent errors. I will define one by one. So the first one is syntax errors. Any violation of rules and poor understanding of the programming language results in syntax errors. So the compiler can detect such errors. If syntax errors are present in the program, then the compilation of the program fails and is terminated after showing the list of errors and the line number where the errors have occurred. So in some cases the line number may not exactly indicate the correct place of the error. In some other cases, a single syntax error can result in a long list of errors. Correction of one or two errors in the program may remove the entire list of errors. So this was the syntax error. And the second one is runtime errors. So what is the runtime errors? Runtime errors are the errors that occur during the execution of the program. Some examples are dividing by zero error, insufficient memory for dynamic memory allocation, referencing an out of range array element. These are not detected by compiler while compilation process. A program with these kind of errors will run but produce erroneous results or may cause termination of program. Detection and removal of runtime error is a difficult task. This was the runtime error. And the third one is logical errors. As the name itself implies, these errors are related to the logic of the program. So logical errors are also not detected by compiler and cause incorrect results. So these errors occur due to incorrect translation of algorithm into the program So poor understanding of the problem and a lack of clarity of hierarchy of operators. Consider following C statement. If A is equal to B, print F equivalent. When A when A and B are float types values, they rarely become equal due to truncation errors. The printf call may not be executed at all. A statement like while A is equal B might create an infinite loop. That was the logical error. And the fourth and last one is latent errors. So latent errors are the hidden errors that occur only when a particular set of data is used. Consider below example. Result is equal a plus b hyphen c minus d. An error occurs only when c and d are equal, because that will make remainder 0. Divided divide by 0 error, and such errors can be detected only by using all possible combinations of data. So these are the types of errors in programming language. So the fourth and last topic is type checking. So what is type checking? Type checking and type conversion. Type checking means checking that each operation should receive proper number of arguments and of proper data type, like a is equal b star j plus t, and minus or basically integer and float data types based operations, and if any variable this a is equal b star j plus t is of other than integer and float, then compiler will generate type error. Type A type is a set of values together with a set of operations that can be performed on them. So the purpose of type checking is to verify that operations performed on a value are in fact permissible, so that the type of an identifier is typically available from declarations, but we may have to keep track of the type of intermediate expressions. So there are two ways of type checking. The first one is dynamic type checking, and the second one is static type checking. So let's start with dynamic type checking. What is dynamic type checking? It is done at runtime. It uses concept of type tag, which is stored in each data objects, that indicates the data type of the object. For example, an integer data object contains its type and values attribute. So operation only be performed after type checking sequence, in which type of tag of each argument is checked. If the types are not correct, then error will be generated. Perl and Prolog follow basically dynamically type checking because data type of variables a plus b in this case may be changed during program execution. So that type checking must be done at runtime. So this is the static type checking. So what is static type checking? So the static static type checking is done at complete time. Information needed at compile time is provided by declaration by language structures. The information required includes: first is for each operation the number, order, and data type of its arguments, and second one is for each variables name and data type of data object. Example: a plus b in this type of a and b variables must not be changed for each constant name and data type and value. Constant is integer x is equal 28, constant float x is equal to 2.087. So in this data type the value and name is specified and in further if checked value assigned should match its data type. So this was the static type checking, and this was my presentation about compiler construction. So hope you all guys like it. Thank you very much.